Welcome to Math on Ice, June 2014 Integral Equations. There are totally 3 questions, 1 question from part B and 2 questions from part C. The first question, the homogeneous integral equation phi of x equal to lambda integral 0 to 1 3x minus 2 into t into phi of t dt. So we need to find the number of characteristic numbers. So here characteristic number is nothing but the lambda, the eigenvalue. So we need to find the number of the values for lambda. Here k of x comma t is equal to 3xt minus 2t. So we find alpha 1 is equal to 3x and then beta 1 is equal to t. Alpha 2 is equal to minus 2, beta 2 is equal to t. So we solve by ax is equal to 0 matrix here and we find the matrix A by the matrix A is equal to 1 minus lambda A11 minus lambda A12 minus lambda A21 and 1 minus lambda A22. This is a 2 by 2 matrix. And where Aij will be equal to integral, your lower limit is a, b and beta I of x into alpha j of x into dx. Now here a11 would be, which is equal to integral 0 to 1, beta 1 and alpha 1, x 3x. So we get 3x squared into dx, which is equal to 3x cubed by 3. Applying the limit, we get 1. And a12 is equal to integral 0 to 1, beta 1 and alpha 2. So we get minus 2t, which is minus 2x into dx, which is equal to minus 2x squared by 2, 0 to 1, which is equal to minus 1. And a21 is equal to integral 0 to 1, beta 2 and alpha 1, beta 2 and alpha 1. So we get here x and here 3x, so 3x squared into dx, which is equal to 3x cubed by 3. And applying the limit, we get it as 1. And a22, which is equal to integral 0 to 1 alpha 2 beta 2. So we get minus 2x into dx, which is equal to minus 1. We'll write the matrix A, which is equal to 1 minus lambda a11. So 1 minus lambda into a11 is 1, and then minus lambda a12, which is minus 1, and then minus lambda a21 is 1, and then we get 1 minus lambda a22, which is minus 1. So this is equal to 1 minus lambda plus lambda minus lambda 1 plus lambda. So this is equal to 1 minus lambda. Just find the determinant of the matrix A and equate it to 0 to get the value of lambda. So 1 plus lambda minus plus lambda squared. So this is 1 minus lambda squared plus lambda squared. When you cancel, you get 1. It is never equal to 0. So therefore, no eigenvalue. That is no characteristic number. It has 0 characteristic number. So no characteristic number. Option 4 is the correct answer. This one is the correct answer. Next question, let lambda 1 and lambda 2 be the characteristic numbers and f1, f2 be the corresponding eigenfunctions for the homogeneous integral equation. Phi of x is equal to lambda integral 0 to 1 xt plus 2x squared into phi of t dt. In the same thing, we have to find the eigenvalue and also we have to verify one more thing. If f1 and f2 are the corresponding eigenfunctions, okay, if f1 and f2 are the corresponding eigenfunctions means they must be orthogonal. So this property satisfies the orthogonality. This is not true. Integral 0 to 1 f1 of x into f2 of x into dx will be surely equal to 0 because f1 and f2 will be orthogonal to each other as they are the corresponding eigenfunctions for the eigenvalue. Yes, now we need to find the lambda value only. K of x comma t is equal to xt plus 2x squared. So alpha 1 is equal to x, beta 1 is equal to t, alpha 2 is equal to 2x squared and beta 2 is equal to 1. So we find the matrix Ax is equal to 0 and the matrix A will be equal to 1 minus lambda A11 minus lambda A12 and then minus lambda A21 and 1 minus lambda A22. X matrix is nothing but C1, C2 which is equal to 0, 0 matrix. But it is not necessary. We need to find this matrix alone and we will find the determinant of the matrix A to evaluate lambda. Now A11 is equal to Aij basically which is equal to integral A to B into beta I of x into alpha j of x into dx, right? So we have a11 is equal to integral 0 to 1 beta 1 which is x and alpha 1 which is equal to x. So we get x squared into dx which will give you x cubed by 3 and we get 1 by 3. A12 is equal to integral 0 to 1 beta 1 and alpha 2. So x2 x cube into dx which is equal to 2x power 4 by 4 0 to 1 which is equal to 1 by 2. And A21 is equal to integral 0 to 1 beta 2 and alpha 1. So we get x into dx which is equal to x squared by 2 which is equal to 1 by 2. And then here A22 is equal to integral 0 to 1 2x squared into dx which is equal to 2x cubed by 3. Applying the limit we get 2 by 3. Now framing the matrix A is equal to 1 minus lambda A11 minus lambda A12 minus lambda A21 1 minus lambda A22. Now find the determinant of A and equate it to 0. So we get 1 minus lambda by 3 into 1 minus 2 lambda by 3 and then minus lambda by 2 the whole squared is equal to 0. So we get 1 minus this 1 minus lambda by 3 and then minus 2 lambda by 3 plus 2 lambda squared by 9. And here it is minus lambda squared by 4 is equal to 0. So we get this as 1 minus lambda by 3, 2 lambda by 3, which is 3 lambda by 3. So we get minus lambda and then plus 2 lambda squared by 9 minus lambda squared by 4 is equal to 0. When you take LCM, it is 36. So 36 minus 36 lambda and this is plus 8 lambda squared minus 9 lambda squared is equal to 0. So we get minus lambda squared minus 36 lambda plus 36 is equal to 0. So that implies lambda squared minus 30 plus 36 lambda minus 36 is equal to 0. Now we use the formula minus b plus or minus root over b squared minus 4ac to evaluate lambda. Lambda is equal to minus 36 plus or minus root over 36 the whole square minus 4 into a into minus 36 divided by 2 into 1. When you find, you will get lambda is equal to, you will find lambda is equal to minus 18 plus or minus 6 root 10. So when you solve this, you will get minus 18 plus or minus 6 root 10. So lambda 1 will be equal to minus 18 plus 6 root 10 and lambda 2 will be equal to minus 18 minus 6 root 10. Now we will find the given options. So the option 1 is true and option 2 is false. Next question, if y is a function from 0 comma infinity to 0 comma infinity is a continuously differentiable function satisfying the given integral equation for t greater than or equal to 0, then which of the following holds? They have squared the function actually. The given function is y of t is equal to y naught minus integral 0 to t y of s into ds. We have in the option y of 0. So we have to find y of 0. So y of 0 is equal to y naught minus when you apply 0 here to the upper limit, this full integral will become 0. So this is going to be 0. So we get y of 0 is equal to y naught itself. Now we will just take the square of the function. Y squared of t is equal to y naught minus integral 0 to t y of s ds the whole square, which is equal to y naught is actually y of 0, right? So y of 0 the whole square will give you y squared of 0 plus integral 0 to t y of s into ds the whole squared minus 2 into y of 0 into integral 0 to t y of s ds. So this is what going to be the direct squaring. So option first one is the true option. Y squared of t is equal to y squared of 0 plus integral 0 to t y of s into ds the whole square minus 2 into y of 0 integral 0 to t y of s ds. This is true. Okay, and what about the other options? They have given in the shortcut method. So we need to find y of t first. We'll find the solution. Now take this equation as star. Now differentiate this equation with respect to t. So we get, as we'll write this again, y of t is equal to y naught minus integral 0 to t y of s into ds, right? So take the differentiation by using Leibnitz rule, y dash of t, this is a constant value. So it will become 0 and then here minus integral 0 to t dou by dou t of y of s ds, and applying the upper we get plus d by dt of t into y of t, and then when you apply the lower it is 0 minus 0. So we get minus, this part is going to be 0 because this y of s is independent of t, so this part will be 0 and we get d by dt of d will be equal to, this part is equal to 1 and y of t will be there, this is minus 0. So we get minus y of t alone. This is going to be 0 and this part is already 0 and dt by dt is 1. So y of t, here we have a negative outside, so minus y of t, and we get y dash of t is equal to minus y of t. So from this we find dy by dt is equal to minus y. So take this y to the left side, dy by y is equal to minus dt. So we get log y is equal to minus t plus c. And as we know that y of 0 is equal to y naught, we get log of, when you apply, we need to find c, right? So log of y naught, that is y of 0, y naught is equal to 0 plus c. So c is equal to log y naught, which is equal to log of y of 0. Log of y of 0. That is what our c is. So we get log y is equal to minus t plus log of y of 0. Now bring this log term to the left side. We get log y minus log of y of 0 is equal to minus t. So that implies log y divided by y of 0 is equal to minus t. So we get y divided by y of 0 is equal to e to the power minus t. So at last the function y is equal to y of 0 into e to the power minus t. This is what the required function is. Now we will find by option here y squared of t is equal to y squared of 0 plus 2 into integral 0 to t y squared of s into ds. So we will verify the second one, option B. So it is given y squared of t is equal to y squared of 0 plus 2 times of integral 0 to t y squared of s into ds. Right, this is what given here. As we know, y is equal to y of 0 into e to the power minus t. Okay, this is what we know. Y squared of t will be equal to y of 0 the whole square into e to the power minus t. This is what we need to get. This is what we need to get. We will check whether we are getting the same thing. Y squared of t is equal to y squared of 0 plus 2 times of integral 0 to t y squared of s into ds, right? So here y squared of s is going to be y squared of 0 e to the power minus 2s into ds, which is equal to y squared of 0. We will just verify the RHS. This is equal to y squared of 0 plus 2 into y squared of 0 integral 0 to t e to the power minus 2s into ds. So y squared of 0 plus 2 into y squared of 0, and when you apply the integral we get e to the power minus 2s divided by minus 2. So 2 and 2 cancels each other. When you apply the limit, y squared of 0 plus y squared of 0 divided by minus 1 into e to the power minus 2t minus e power 0, and that is equal to y squared of 0 minus y squared of 0 into e power minus 2t minus 1. When you take out y squared of 0, we get 1 minus e to the power minus 2t plus 1. So 1 and minus 1 cancels each other. We get y squared of 0 negative outside e to the power minus 2t. This is your y squared of t. No, it is not y squared of t. Y squared of t should be equal to y squared of 0 into e to the power minus 2t. Here we are getting a negative. So second option is false. This is not true. And we find y squared of t is equal to y squared of 0 minus integral 0 to t y of s into ds. Y squared of t is equal to y squared of 0 minus integral 0 to t into y of s into ds. So that is RHS is equal to y squared of 0 minus integral 0 to t. What is our y of s? Y of s is y of 0 into e to the power minus s. So y of 0 into e to the power minus s into ds. So y squared of 0 minus y of 0 integral 0 to t e to the power minus s ds, which is y squared of 0 minus y of 0 e to the power minus s divided by minus 1. Here it is 0 to t, y squared of 0 plus y of 0 into e to the power minus t minus e power 0 will be 1. So this is abruptly not equal to y squared of t. Not at all possible. Therefore, we get the next option, third option, to be wrong. Next one is y squared of 0 minus 2 into integral 0 to t. Actually, when you see from these two options, a negative is missing here, right? So eventually this is going to be true because here we got a negative only outside. So that was the mistake we get for getting y squared of t, right? So here they have given the option as y squared of t is equal to y squared of 0 minus 2 integral 0 to t y squared of s into ds. Now this is equal to y squared of 0 minus 2 into integral 0 to t y squared of s ds, right? So integral 0 to t y squared of s into ds. That would be equal to y squared of 0 outside, and this part will give you e to the power minus 2t minus 1 divided by minus 2. So we get y squared of 0 into e to the power minus 2t into minus 1 divided by minus 2. So this is equal to y squared of 0 minus this one minus 2 and minus 2 cancels. We get plus y squared of 0 e to the power minus 2t minus 1. So when you take out y squared of 0, we get 1 plus e to the power minus 2t minus 1. So we get the answer. So this is actually equal to y squared of t is equal to y squared of 0 into e to the power minus 2t. We got the exact solution. This is what we need, right? So this is true. The fourth one is true. Thank you.